Okay, everyone, we're going to finish up chapter 8.3 notes, so make sure you have those out. At this point, you're able to do chapter 8.1 homework set and 8.2. So stick with me. This one should be fairly short, but it's very difficult, okay? This is where you're going to have the most trouble, so pay close attention. All right, a word equation. Guys, this is like the chemistry version of a word problem in math. So yeah, you know it's already going to be kind of rough. You have to change it into formulas to give a good equation, then you have to balance the equation. One thing I want to cover first are the 7 diatomic molecules. On your green sheet, we should have already filled in these holes, or these blocks for these elements with a little subscript of 2 next to each one. And here they are. In hydrogen's block, put a little 2. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All of those you should have a little 2 in. Now let's be clear. When I say hydrogen, you write H2. Just hydrogen, nothing after it, nothing before it, okay? That's when you write H2. Now, if it says nitrogen, and that's the only word there, you write N2. If it has another word in front and it's nitride, then you need to go write that it has a -3 and go find the metal and its charge and cross them. If it has a prefix out front like dinitride or dinitrogen, sorry, my computer's frozen, then it'll be 2, but if it said tri here, it would be in 3, and it's attached to something else then. So careful, guys. Only when it is this actual element do you automatically put the 2, okay? So, let's look at some training wheel exercises here. I'm going to put both of these up so that we can get started. Now, on the first one, the way to start this is to figure out, well, what's the formula for just magnesium? Well, that's just Mg, right? Plus, notice it says oxygen, it's just the element, so he's going to float around in a pair, he's going to double bond to himself. And that's going to yield a compound, magnesium oxide. Now, you have a metal with a nonmetal, so you better go find some charges. There are no prefixes there to tell me how many of each. So it's ionic. Magnesium is in group 2, making it a +2 charge. Oxygen is in group 16, meaning he needs 2 more electrons to be stable. Well, look at that. +2 and -2. I only need 1 of each to be balanced. So magnesium oxide, whenever they come together, it's just going to be 1 of each, Mg and O. Alright. Once your equation is written, you go back and you balance. Start left to right. Magnesium's happy on both sides, but oxygen goes from 2 to 1. Fix that. Put a 2 in front. And then look who that affected. Well, now magnesium needs 2 on the left. Okay? The next example is a little longer, so stay with me. Here you have potassium iodide and lead 2 nitrate. Well, metal, nonmetal, metal, nonmetal. So these are all ionic, guys. Find potassium on your green sheet. It's in group 1. It's a +1. Iodine's a halogen, group 17, -1, only needs 1 electron. So when I go to write these out, it's just a 1-to-1 ratio. Alright. Then we hit lead. Well, my group number doesn't help me with lead, okay? But this parentheses does. It tells me that the charge here is +2. And then nitrate. That's not nitride, that's nitrate. You have to flip over to the back of your green sheet and find the ion. Nitrate is NO3. Whew. And it has a -1 charge. So when I look here, I'm going to need 2 nitrates, 2 negative ones to balance with the +2. Or remember the trick, the 2 will go and be nitrate subscript, the 1 will be lead subscript. So it's going to be PB, and I only need one of those. NO3. Make the best out of this as you can, okay? And I'm going to need 2 of those. Okay? Then, that's going to yield, and I'm going to have to drop down for mine, okay? So you keep going left to right. It's going to be potassium and nitrate, so that's going to be a 1-to-1 ratio. So that's just K NO3 I'm sorry guys, my thing is really having some rough time here. That's a 3 there. Plus lead 2, so that's a plus 2 right there. And a -1 for iodine. Oh, my lead doesn't even have a 2. Make the best as you can, okay? So that's going to be P PbI2. PbI2. Make sure yours says PbI2 right there. I really hope you're listening or you're going to have this all wrong. Alright, now, then we have to go back and balance. Well, you'll see, if I start with my NO3, that I need 2 on the right. And because I need 2 on the right, I have to go put a 2 in front of my Ki. And then I'm completely balanced because my I already has 2 on the right. Okay? That was more like a 2. Alright. So, let's start talking about how we can add some more symbols into this. Not that anybody wants to add symbols, but we could if we needed to, okay? On here, here's your regular yield sign. This is telling you it's a reversible reaction. Here, I'm telling you that whatever it is a solid, so we might see this as, like, if I said iron, metal, or iron powder, or something of that sort, you'll write that right down here like you would a subscript, okay? You're just telling me the state that it's in. You put this little down arrow to show it's a precipitate. L for liquid. Now guys, that when we write that in script, that's a cursive L. AQ, you're going to use this one a lot. It means whatever it is was dissolved in water, or it's aqueous. G is for gases. Then we've got some other ones. You could use this up arrow instead of the gas. If I have a triangle or the word heat above my arrow, it means I have to heat it for the reaction to happen. These two indicate what pressure, or that pressure must be applied for it to happen. This is the temperature at which it has to happen. And this is when you have a catalyst. Since it's not actually a reactant or a product, it goes over your arrow. Okay, a catalyst just speeds it up, lowers the activation energy. So here's a couple of practice. Now, hit pause, do the best you can on number 1, and I'm going to come back and walk you through it here in just a second, so hit pause now. Alright, so here we have iron, but they're telling you it's a metal, so you know it's in the solid state. N is another way of saying plus. Chlorine gas. Notice it's just chlorine, so on your green sheet you should have that little 2 written in. That's going to be what catches you on the first few homework sets, okay? Reacts to form. Well, that means put my arrow in there. And then if you notice, you've got solid iron 3 chloride. Metal, non-metal, get charges. Well, this one's plus 3 because of my Roman numeral here. Chlorine's always -1. So when I write it, it's going to be Fe, only one, and then chlorine, oopsie, I'm going to need 3 of them. Don't forget that little solid bit of information, that's important. Alright, so look, iron's happy on both sides, but look at chlorine. Here's a hint, guys. You never want odd numbers if you're trying to balance that one. If it doesn't just work out that way, you always want to make it even. Fastest way to do that, slap a 2 in front of it. Now I've got 6 chlorine. How do I get 6 out of this side? Add a 3. But look at your iron now. You have to add a 2. Okay. Once you have that down, push pause. And you need to work on number 2. Aqueous solutions of barium chloride and sodium chromate react to produce a precipitate of barium chromate in an aqueous solution of sodium chloride. Whew, lots of words. I'm going to come through and answer in just a second, so hit pause now. Alright, I've got barium and chloride. There's 1. And is a plus sign. Sodium chromate. Both of those are aqueous, okay? So you have to note that. React to produce. There's your arrow. Then you're going to have a precipitate, it's important, of barium chromate and an aqueous solution of sodium chloride. Alright, go find all your charges. Hopefully you already did that, so I'm just quickly going to write them in. That's a 2. Chlorine is -1. Sodium +1. Chromate, it's a TE ending, it's on the back of your green sheet, is a -2. It's a 2. Alright, here we go. Sorry if this handwriting gets bad, guys. Barium chloride should look like BaCl2. That's a 2. And that's aqueous. Oh my heavens, y'all. Sorry. We're like back in the Stone Age here. And sodium chromate should be Na2CrO4. Okay. Na2CrO4. Gracious, guys, this is so bad. I can't handle that. Let's see if we can get this to work any faster. Oh, so much better. Barium chloride, aqueous, plus sodium, oopsie, that's a 2, chromate, also aqueous, reacts to form a precipitate of barium chromate, and since they're both 2, it's just a 1-to-1. I'm going to put my down arrow for my precipitate, and an aqueous solution of sodium chloride. Okay, now we've got it written. Last thing we have to do is go back and put in our subscripts, or sorry, not subscripts, our coefficients. Barium's happy, chlorine is not. Well, that fixed sodium's problem, and chromate is happy. So that's it. All you needed to put was a 2 in front of NaCl. Alright, goodness gracious, this is ugly. Try these two, okay? In 1 second, I'm going to have to pull up the other one and answer this. And then we will move on. Alright, for that first one, you've got aluminum, solid aluminum carbonate. So aluminum is Al, and its charge is usually +3. Carbonate is CO3, charge is usually -2. And I know this is a solid, okay? Plus, oops, no.